hypotenuse was angle subtended by the chord. Today, what we are going to discuss in today's class is, if we have an arc, like by if we have a chord, sorry, this is a chord, right? If we have a chord, okay? Like by if you have a chord, and if you draw a perpendicular from the center of the circle, okay? From the center of the circle, then what and all comes into picture, okay? There are two theorems that comes into picture again. We have two theorems based on this concept itself, okay? Okay, let's study these two theorems. Before that, we just have a simple concept. Okay. Okay, we'll directly move to the theorem number 3. The theorem number 3, before going to theorem number 3, I've just told you what we are going to discuss. What we are going to discuss, Laiba? It is nothing but for this chord. Yes. For this chord AB, if we draw a perpendicular का मतलब क्या होता है? What does perpendicular mean, beta? Perpendicular is 90 degree, right?
Yes, yes.
Yes. If we draw a perpendicular from the center of the circle, center is O, okay? If we draw a perpendicular from the center of the circle to this chord AB, then we have a simple ruling that this bisects AB. Bisects का मतलब क्या होता है? Divides it into two?
Equals.
Yes. So it divides it into two equal. So this chord is divided into two equal sides. So this is the theorem number 3. Okay. Theorem number 3 states that, okay, the perpendicular drawn from the center of the circle to the chord. Okay? Okay. Are you understanding the concept? The perpendicular from the center of the circle to a chord bisects the chord. Bisects का मतलब it divides the chord into two equal sides, two equally. It divides the chord equally, correct? Understood? So this is theorem number 3. How will you prove this, Laiba? Please. Okay, what is the Laiba?
Why? What?
Perpendicular to the arc. Can't you hear me, Laiba?
No, your voice is breaking.
I'll just fix it. Okay. Okay, it might be fine by now. Can you hear me now?
Yeah.
Okay, Alhamdulillah. Okay. Laiba, I cannot hear you.
Hello.
Okay, am I audible? Am I audible?
Yeah.
Okay, mashallah. So the perpendicular drawn from the center of the circle, okay, to a arc, to a chord AB. Then what does it does? Better, what does it do? What does this perpendicular do? It bisects the chord, right? Bisects the chord का मतलब क्या होता है? It divides the chord into two equal parts. That's all, right? Yes.
Yeah.
So let's prove this theorem. How will we prove this theorem is, we have this one. It's quite easy proof, okay? Okay. We have a circle. The same circle is written here. However, the same circle that I written is written here. The circle is drawn. AB is a chord, correct?
Yeah.
Is AB the chord? Okay. There is a midpoint. Where is the midpoint? Midpoint. The center of the circle. Where is the center of the circle? It is O, right? Okay. From there, we are going to draw a perpendicular. This is a construction, right? If we draw if we construct a perpendicular M, if we are going to draw a perpendicular through O, then it bisects at M. Okay, let's write this down as M. ठीक है. Now we are going to prove that AM is equal to MB. What we are going to prove? That this perpendicular bisects AB. Bisect का मतलब it divides AB into two, AM and MB, which are equal to each other. This is to prove, okay? To prove. Right, Laiba? To prove is
Yes.
AM equals to MB. Okay. So what is given? Now please tell me what is given, beta. Chords are given, correct? Chord is given, one chord AB is given, correct?
Yes.
And then perpendicular OM is drawn from the center, right? This is given. It is drawn till M. Okay. Next, what to prove? To prove is nothing but AM is equal to MB. It is already told. AM is equal to MB is to prove, correct? Now, how to prove this is we are going to create again the two triangles. How will we create the triangles, beta? Let's do a construction, small construction. Join OA and OB. Done? Okay, this is the construction library. Now, how will we find AM is equal to MB? Just the simple thing, you are going to consider two triangles OMA and OMB, correct?
Yes.
Now, quickly tell me what equates what in these two triangles, beta. Which is equal to what? Which things are equal? Please tell me soon. It's very easy. You have to interact. Liba, what is equal in these two triangles to prove the congruency? This is a midpoint. Is it not OA is equal to OB? Liba, I cannot hear you. Is it not O equals to OB, beta? Yes, right? Liba, you're not audible. You're not audible, beta.
Can you hear me now?
Okay, can you hear me out?
Yes.
Okay, mashallah. Now, to please tell me what and all comes into picture here, beta. What are the things that you can equate? Which things are equal here, Liba? O is equal to OB is done. Then what more,
Yes.
Liba?
AM is equal to MB.
No, this is to prove. We have to prove this. AM is equal to MB. It's not given. The perpendicular from the center of the circle to a chord bisects the chord should be proven, right?
Yes.
Yes, this is not given. AM is equal to MB is to be proved, right?
O is the midpoint.
Okay, wait, just a second. O is equal to OB is done. And what more, beta? O is equal to OB is done. OM is common, right?
Yes.
OM is common. Done. Two things are OM is common, so OM is equal to OM. OM equals to OM. Two are done. And do you remember what is drawn? Perpendicular is drawn. So angle AMO is equal to OMB, which is equal to, is it not 90 degree?
Yes.
Yes. So two angles are equal. Angle AMO is equal to angle OMB, which is equal to what? 90 degree, right, beta? So, which postulate do you apply here? Two sides and one angle. Which are postulate? Live, which postulate will you apply, beta?
That is.
Excellent. It is yes postulate. So, this gives BM is equal to AM, which is due to the corresponding parts of the congruent triangles. Understood the concept? Please
Yes.
concentrate. I'll explain to you again. I guess you haven't heard it right. Okay, I'll explain to you again. The statement is the perpendicular from the center of a circle to a chord. This is given, okay? A perpendicular dot is drawn from the center of this circle to this chord AB. Okay, this is the statement. And this is to prove bisects the chord. What to prove? AM is equal to MB, correct? Okay, so you want to prove that AM is equal to MB and B, what is given is chord and the perpendicular, right? Perpendicular to AM. So this is perpendicular, matlab this is 90 degree and this is 90 degree, right, beta? So
Yes.
construction, what construction will we do here? We will just join these two dots and make two triangles. Okay, two triangles. If we make, what three things do you add here to prove? Please write all of these down because it is not given in your textbook. Are you writing it, beta?
Yes.
So
Yes.
OA is equal to OB because of radii, and what more? And AMO, AMO, angle AMO is equal to angle OMB, which is equal to 90 degree. It is given already. And then OM is equal to OM, which is common. So all of, from all of these three, ASA postulate or SAS postulate applies, right? SAS postulate, from the SAS ruling, what we can prove here is that these two triangles are congruent. If these two triangles are congruent, then there applies a ruling called CPCT, corresponding parts of the congruent triangles. Understood?
Yes.
Okay, so BM is equal to AM. That's what we are going to prove. So what does this theorem state, Sliba? Just please tell me without saying. What is this theorem called? If we
And
draw some perpendicular from the center of the circle to the chord, then it bisects the chord. What does this mean, beta? Yes, please explain.
um, if um if it's perpendicular from the center, then it no, if it's perpendicular from the center to the chord, then it will divide the chord into two equal halves.
Yes, it divides into two equal halves. Very good. So now tell me what to prove here.
And we have to prove AM is equals to BM.
Excellent. And how will we prove this, beta? What did we make here? We made a construction, right? What
Yes,
construction did we
we
make here? We just joined the two dots and made it a triangle, right?
yes.
Okay, now tell me how did you prove this two triangle, congruence in two triangles?
We wrote two congruent sides and one congruent angle, and
Yes, two
AM is
angles are
equals
nothing but
to
two angles are nothing but
um,
which are 90 degree, right? Because it is given perpendicular.
yes.
Okay,
Mm, And then we
then
got
which
the
one did you get?
common side.
Two radii, right? And one common side. OM is common side.
Yes,
This are radii. Okay.
yes.
So from this three, which postulate did we apply with the?
SS.
Yes. So from this, what did we prove, Liba?
We proved BM is equals to AM by CPCT.
Excellent. This is the answer. That's all. Done? Understood?
Yes,
Have you written it down?
yes.
So we have next a theorem named theorem number 4, which is exactly same, but we are going to just converse this statement. Okay. So the converse statement is nothing but the, what does converse mean? Is opposite of the previous statement, correct? So
Yeah.
the statement here is the line drawn through the center of the circle to bisect a chord is perpendicular to the chord. Okay. The line drawn through the center of the circle. The statement is nothing but just the converse, right? I'll tell you
Yes,
how. A line drawn through the center of the circle to bisect a chord is perpendicular to this chord. So we are going to prove that this is equal to 90 degree. Okay. This angle and this angle are equal. You're just going to prove that two angles are equal. If two angles should be equal, then how will it be? It should be 90 degree itself, right? So here if it is AB as a chord, and if they have already told that it bisects, okay? They already told us AM is equal to MB, correct? Why is it so? Because we are going to converse the previous theorem, that's all. So how will we prove this, Liba? It is same procedure as previous, same procedure. Do you know how to prove this? Can you give it a try? It's the same as previous one. Come on, just start with the proof beta. Please tell me what to prove. What are we going to prove here, Liba?
we have to prove that OM bisects AB.
No, bisect is already done. Bisects is done. Theorem number 3 is done. Okay. Bisects ka matlab AM is equal to MB. Right? This is
Yeah.
already proven. Now in theorem number 4, the line drawn through the center of a circle to bisect a chord, this is a statement. This is a proof. This is to prove is perpendicular to the chord. What is it? is perpendicular to the chord. Matlab you are going to prove these angles are equal. That's all. What is given is AM is equal to MB is given. Okay?
Yeah.
Okay? What we are going to prove is just these two angles are equal. It's just same as this theorem is not given. Please write it down. I think few parts of it is given and not fully. Please write this down. Okay? So you're given AB as a chord. Correct? We are going to prove how we are going to prove. We are given AB as a chord with a center O. And what is O? O is joined to M. Correct? What is M? It is a midpoint M of AB. So what to prove, beta? That OM is a perpendicular drawn to AB. That's all. So what do we construct? It's same as the previous OA and OB is constructed. So now tell me what will you consider in these two triangles, beta? What can you consider to prove the congruence in these two triangles, Laiba? Please explain.
Um,
What can we consider? Is it not
O
OM is equal to OM already? Yes,
is equals to OB.
common. Again, OA is equal to AB. Excellent. Two sides are done. Two sides are done. Now, what can we?
O OM is common
No, we
side.
already have this one, right? There's something bisect, right? Is it not AM is equal to MB already given?
Yes.
Yes, it is already given because here it's already O is joined the midpoint of M of AB. So AM is equal to AB is already given. You have to write it down as given. So OM is equal to AM is equal to MB is given. So three sides. So which postulate will you apply?
SSS.
SSS postulate. From the SSS postulate, these two triangles are proved congruent. If these two triangles are congruent, then angle OMA is equal to angle OMB. That's all. Which is equal to 90 degree. Understood?
Yes.
Okay. Can write this down. Do you want to write it? Just check
Yeah.
the textbook. If it's there in the textbook, then no problem. We'll just move for the next thing. Okay. This is theorem number 4. Okay, mashallah. We are done with the 9.2, the subtopic. Have you understood both of the theorem better?
Yes.
Can we just revise? What did we study in both of this theorem? Is it not that if there is a circle and a perpendicular drawn from the center of the circle to the chord, correct? Then what does it do at first? It bisects the chord. That's all. Correct? Theorem number 3 states that if a perpendicular drawn from the center of the circle to the chord, then it bisects the chord. Bisects matlab it divides the chord into two equal parts. Correct, Laiba?
Yes.
Yes. What was the converse of the theorem number 3? That is theorem number 4. It just states that if there is a line that is drawn to the chord AB and which already bisects the chord, then this line is always perpendicular. Correct? This was the statement for theorem number 4. Understood? Both of this theorem are clear now?
Yes.
Are they clear, beta? Simple. The proof is very simple. You are just going to draw a construction and then prove it. That's all. So we have 4 theorems. So 4 theorems are done. So we'll just see the next part. It is nothing but equal chords and the distances from the center. Okay. Equal chords ka matlab kya hota hai? If you're drawing equal chords, for example, if you're drawing a 2 centimeter chord here and a 2 centimeter chord here and a 2 centimeter chord here and a 2 centimeter chord here, if you measure this distance from the center of the circle to this chord, okay, beta, center of the circle to this chord, center of the circle to this chord, how will you measure the length, beta? Do you know? How will you measure the distance? Laiba, how will you measure the distance between the center of the circle and this chord? Do you not just consider it the center and the midpoint of this to measure the distance? Yes, right?
Yes.
Yes. So I'll just tell you how we are going to do that. See here, if you have this figure, okay, if you have all of these points, how will you actually calculate the distance from this figure, beta? Consider this is a ray AB, okay? Yahan se point, you have these many points. Now tell me, just consider this figure, okay? Now tell me, which line will you use to measure the distance? Do you use PL to measure the distance AB? Do you use this line PL to measure the distance of point P from AB? Yes or no? Laiba, just tell me which point will you use? Just tell me which point will you use to measure the distance of AB from point P? Will you use L1, L2, M, L3, L4, L5? Which will you use? Just tell me that. Laiba, you're not audible.
Hello.
Yes, am I audible now?
Yes.
Okay, Laiba, just tell me which point will you use here to measure the distance of AB from point P? Do you use L1, L2, M, L3, L4, L5? Which point will you use to measure the distance of point P from AB? Just give it a guess, beta. Laiba, just guess it. I actually cannot hear you. Okay, Laiba, am I audible? Okay, there's some network connectivity issue. Yes. Okay, Laiba, I'm here. Am I audible to you now? Can you rejoin? Assalamu alaikum. Ji, assalamu alaikum. Can you hear me out, Laiba? Please unmute your microphone.
Hello, can you hear me now?
Yes, yes, it's fine. What was it? What was the problem?
I don't know, I think it's an internet issue.
Okay, okay. Everything was fine at this end. I wasn't able to hear you actually.
Yeah.
Okay, mashallah. I have so damn shit. Okay, fine, beta. So, what were we discussing here? How to calculate the actual distance for this arc or this chord AB from the point P, Laiba. What actually? Please tell me which point will you consider to mark the distance between these 2 points, this line and this point. आप क्या कंसिडर कर सकते हो बेटा? कौन सी लाइन आप कंसिडर कर सकते हो इसका डिस्टेंस कैलकुलेट करने के लिए इस पॉइंट से? प्लीज टेल मी. Lab, I cannot hear you again. Okay, just give it a guess, beta. Give it a guess. Give it a guess. No problem.
This L1, L2.
Okay, you are saying M1, L2. You know how we'll calculate actually distance is actually the perpendicular thing is called as the distance, right? ये point से AB को distance करने के लिए we'll just consider the straight line. We'll draw a straight line from this to this and then we'll consider it, right?
Yes.
Yes. So here to calculate the actual distance, what we consider is PM. Which line will we consider? PM, not all of these lines. Because the bend lines won't give you the actual length, right, beta? So the actual length will be actual distance between the point P and the chord AB will be given by this straight line, okay? This is just the side point that I was going to explain to you, okay? This is the side point that I was going to explain to you, that the length of the perpendicular from the point to a line is the distance of the line from the point, okay? Understood? So in a circle, okay, beta, if there is an arc, then how will you measure the distance of this arc or this chord from the center of the circle, Laiba? What will you do? You'll make a point and then draw a straight perpendicular to it, right?
Yes.
Okay, this is what I was going to explain to you, not this one. This one won't give you these things. The side lines won't give you the actual length. This is to remember, okay? You have to remember this. Which will give you the actual length of the point O to the arc to the chord? Which one? This line, right? This perpendicular will give you to the actual distance, correct? So this was explained here. The length of the perpendicular from a point to a line is the distance of the line from the point is actually the perpendicular distance. Understood? Okay, this is just the side point. You don't have to memorize or something. It's just for you to remember, okay? Now, please tell me what is the distance of the diameter from the center of the circle? If you have a circle, if you have a center, what is the distance of the diameter from the center of the circle? Is it not 0? There is no distance here. It stands on the center, right?
Yes.
So there's no distance between the diameter and this one. It is 0. Okay, it's nothing. It's negligible. It's just something to know for the curiosity. For example, if you have this arc and if you have the center, and to measure this the distance between this center of the circle and arc, what you have to do is you have to draw a straight line that is perpendicular to this arc, and this OM gives you actual distance, right? Gives the Actual distance of, what does this give you, beta? Actual distance of point O from
Quantum.
center from chord, okay?
Yeah.
Center from the chord that we have drawn. Chord is the main. We are only dealing with the chord in this chapter, okay? So it is about chord. So what is the distance of the diameter, which is the longest chord from the center? It is nothing but 0, right? Because the center lies on the diameter, then the distance is 0. That's all. It's just for the curiosity. You don't have to memorize this, but remember it, okay? How to calculate is nothing but from the center of the circle. So from the main, from the topic, the main topic called, what is the topic called? Topic is nothing but, the topic that we have here is the equal chords and the distances from the center, okay? What we are going to deal here is the chords and the distances from the center. Understood, beta? We are going to deal with this topic here. From that topic, we have another 2 theorems, okay? Another 2 theorems. You do not have to prove this, but you have to remember these 2 theorems. Okay, Laiba? Okay. So we have theorem number 5. Okay, this is theorem number 5, which states that equal chords of a circle are equidistant from the center. What does this mean? If you draw equal chord 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter, then they are actually equidistant from the center. This one will be 2 centimeter, this one will be 2 centimeter, this one will be 2 centimeter, this one will be 2 centimeter. Understood? So equal chords of a circle are equidistant from the center. Understood, beta?
Yeah.
Okay, this is theorem number 5, and theorem number 6 states that, okay, this is just the diagram that I have drawn, okay? If you draw the equal chords, then the distance will be equal. So OM is equal to ON here in this circle, and in this second circle, OM it's just drawn. Okay, if there are 2 congruent circles as well, if 2 different circles, congruent we had discussed, right? If 2 different circles, if you draw and you have equal chords in it, okay, and then you draw up OM and ON, then OM is equal to ON. Understood? If there are 2 equal arcs in 2 different circles or 2 congruent circles, then also the perpendicular distance from the point O is equal. Okay, beta? Okay, so this OM is equal to ON if it is in the same circle, if the chords lie in the same circle. If the OM is equal to ON if it lies in the 2 congruent circles. Okay? 2 congruent circles. Okay, understood, Laiba?
Yes.
Okay, any doubts in this? This is just a theorem number 5. We'll see this theorem number 6. It states that chords equidistant from the center of the circle are equal in length. It is just the converse of the theorem. What it states that if you draw something, chords equidistant from the center of the circle, okay, if the distance of the chords are 2 centimeter, 2 centimeter distance between each chord is same, then these chords are also equal. Understood? Have you understood theorem number 5 and theorem number 6?
Yes.
Any doubts in it? It's nothing but if you draw the chords in a circle, which are equal in length, then if you measure the distance between each chord to the center of the circle, then you will find that all these chords, the distance between the chords and the center of the circle will always be equal, okay? And converse of this theorem is if you draw equidistance chord, if you find the 2 centimeter as a distance between the chord and the center, then the center of the circle will have, then these chords will have the equal length, okay? It's just the converse of theorem number 5. That's all. Understood? Any doubts in it?
No.
Okay, mashallah. So we just have one example problem. I think this is enough for today. We'll discuss the problems in next class lab, okay? So that you will remember it better. So today you have got 4 theorems to study. Will you study all of these theorems and come for the next class? Because you have a weekend, do you have a test this Sunday?
Yes.
So we have discussed theorem number 5, theorem 3, 4, 5, 6 in today's class. Theorem 3, what does theorem 3 states? Do you remember? What does theorem 3 states? What does theorem 4 states? 5, 6? Okay, please memorize the statements, inshallah, and come in the next class. Okay, we will have a quick recap on Monday's class. Okay, beta?
Yeah.
Jazakumullahu khairan. Take care of yourself. Have a happy weekend. If any doubts, you can just text me. I think you are going to prepare for the test, or that is on Saturday, right?
Yeah.
Okay, mashallah. So do well in the exams or tests. Take care of yourself. Allah Hafiz. Fi amanillah. Subhanakallahumma bihamdika nashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamu alaikum wa rahmatullahi